Hi class, this is Xiaoying. Today I'm going to talk about Pigeonhole principle from chapter 2.19 for my bonus presentation video. We first need to figure out what is Pigeonhole principle. By definition, on the book, Pigeonhole principle is if k plus 1 pigeon are placed into k pigeonhole, then at least one pigeonhole will contain 2 or more pigeons. On the other word, if we have more pigeons than holes, then there are at least one hole must have at least 2 pigeons, like this. Let's do some simple example for us to make it clear. How many people in the classroom so that we can make sure at least 2 of them have a birthday in the same month? Let's review about our pigeonhole principle. If k plus 1 pigeon are placed into k pigeonhole, then at least one pigeonhole will contain 2 or more pigeons, right? Now, we are looking for 2 people that have a birthday on the same month, which means our pigeonhole is 12 months. We now have 12 pigeonholes. Then, by pigeonhole principle, we know that if there are 30 people in a room, at least 2 of them are sure to have a birthday in the same month. So, what about at least 3 of them have a birthday in the same month? Similarly, we know that 24 pigeonholes. We now have 24 pigeonholes. Then, by pigeonhole principle, we know that if there are 25 people in the room, at least 3 of them are sure to have a birthday in the same month. From the last slide, we know that if 2k plus 1 pigeons are placed into k pigeonhole, at least one pigeonhole will contain more than 2 pigeons. By the same way, we know that if 3k plus 1 pigeons are placed into k pigeonhole, at least one pigeonhole will contain more than 3 pigeons, such that we have this view. If m pigeons are placed into k pigeonhole, then at least one pigeonhole will contain more than m minus 1 divided by k pigeon. Let's move on to next theorem, which is Ordish and Zach's theorem. It said that given a sequence of n to the power of 2 plus 1 distinct integer, neither there is an increasing subsequence of n plus 1 term or a decreasing subsequence of n plus 1 term. It's interesting, right? Now, let me use some example to make us have a better understanding of pigeonhole principle. Suppose that 9 integers from the set of 1 to integer 81 are driven, so that there are 2 disjoint non-empty sets with the same sum. Let S to be the set that contains 9 integers. Then S is a subset of the number from 1 to 81. There are 511 ways of picking a non-empty subset of S. The sum of elements from S would be as small as 45 or as large as 693. So, we have 511 possible ways of picking a non-empty subset of S. But the number of possible sum is 648, which is way more than 511 possible ways. Then By Pigeonhole principle, we know that there are two disjoint non-empty subsets with the same sum. Let's move on to the next example. To prove that 70 points are placed into 4 cm by 4 cm square, then we can find 2 points with distance at most square root of 2 cm. We first draw a 4 cm by 4 cm square and divide it as 16 1 cm by 1 cm square. Then we have choose point in the small square. That distance of this point must be less than or equal to square root of 2 cm, like this. Then we have 70 points in here and 60 square. So by Pigeonhole principle, there must be a square that contains 2 points, which means there is at least 2 points with distance at most square root of 2 cm. Here is my bonus presentation video. Thank you for watching.